We now have part 2 of the discussion on parametric surfaces. Here are the exercises or examples for this part. If you want to try answering them first, you may pause the video. If you want to see the solutions, you may continue playing. Let's now discuss the first item. Kung medyo mahina, pwedeng pakilakas lang ng konti yung volume. Let S1 be the surface parameterized by the vector function for u cosine v I hat plus u sine v j hat plus u k hat. For letter A, describe the constant u curves of S1. The parametric equations for this surface are x equals 4u cosine v, y equals u sine v, and z equals u. To describe the constant u curves, consider natin yung case na u equals 0, tapos yung u is non-zero. Unahin natin yung sa u equals 0. If u equals 0, then from the parametric equations, we get x, y, and z to be all equal to 0. So the constant u curve when u equals 0 is a point whose coordinates are 0, 0, 0. We now consider the case where u is non-zero or u equals u naught where u naught is not equal to 0. Here, x equals 4u naught cosine v. Substitute u equals u naught doon sa x component. Y equals u naught sine v. Substitute u equals u naught doon sa y component. And z equals u naught. Substitute u equals u naught doon sa z component. From the first equation here, we get x over 4u naught equals cosine v. And from the second equation, we get y over u naught equals sine v. Express natin in terms of v yung x over 4u naught squared plus y over u naught squared. So that this expression is equal to square lang ito plus square nito. So this is equal to cosine squared v plus sine squared v, which is equal to 1. Yung left hand side equal to sa x squared over 16 u naught squared plus y squared over u naught squared. Hence, x squared over 16 u naught squared plus y squared over u naught squared equals 1. Itong equation na to, on the plane z equals u naught, this represents an ellipse. Therefore, the constant u curve when u is non-zero is an ellipse. So we're now done with letter A. We now proceed to letter B. Describe the constant v curves of S1 where v is pi over 2 and v equals pi. Unahin natin yung case na v equals pi over 2. If v equals pi over 2, then x equals 4u cosine pi over 2. Substitute v equals pi over 2 dun sa x component. Cosine pi over 2 is 0, so x equals 0. Y equals u sine pi over 2. Substitute v equals pi over 2 dun sa y component. But sine pi over 2 is 1, so y equals u. Also, z equals u. Observe that y equals u and z equals u. So, y equals z. Itong equation na to, on the plane x equals 0, this represents a line. Therefore, the constant v curve when v equals pi over 2 is a line. If v equals pi, then x equals 4u cosine pi. Substitute v equals pi doon sa x component. Cosine pi is negative 1, so x equals negative 4u. Y equals u sine pi. Substitute v equals pi doon sa y component. Sine pi is 0, so y equals 0. And then z equals u. Observe that x equals negative 4u and z equals u. So that x equals negative 4z. Itong equation na to, on the plane y equals 0, this represents a line. Therefore, the constant v curve when v equals pi is a line. So we are done with letter B. We now proceed to letter C. Identify the surface S1. Balikan lang natin yung mga parametric equations for this surface. X equals 4u cosine v, y equals u sine v, and z equals u. From the first equation, we have x over 4 is u cosine v. Gawin natin, kunin natin yung x over 4 squared plus y squared. So that this expression is square lang nito plus square nito. This is equal to this part. Factor out u squared, we get this. But since cosine squared v plus sine squared v equals 1, then this is equal to u squared. Pero yung u equals z, so this u squared equals z squared. And then this left hand side is equal to x squared over 16 plus y squared. Hence, x squared over 16 plus y squared equals z squared. Pwede rin nating isulat to as x squared over 16 plus y squared minus z squared equals 0. So the Cartesian equation, we can write this as x squared over 16 plus y squared minus z squared equals 0. This is an elliptic cone. So tapos na tayo sa example na to. We now proceed to the next example. Let S2 be the surface parameterized by this vector equation where u is greater than or equal to 0. So identify the surface S2. Observe that the vector equation for S2 is the same as the vector equation for S1. So we expect that the Cartesian equation for S2 is the same as in S1. So it's also x squared over 16 plus y squared minus z squared equals 0. Pero dun sa S2, u is greater than or equal to 0. Since z equals u, then z is greater than or equal to 0. So S2 is not the entire elliptic cone, but a portion of it where z is greater than or equal to 0. para makita natin yung difference between the two surfaces discussed. This is a portion of the graph of S1. Pinutol lang natin sa plane na to sa taas at sa baba. But this is an elliptic cone. Meanwhile, S2, we show here a portion of the graph of S2. Pinutol lang natin sa plane to. As you can see, wala na yung nasa babang part. Since in S2, u is greater than or equal to 0, but since z equals u, then z is greater than or equal to 0. So, yung portion lang ito ng elliptic cone nasa taas ng xy plane. So, that ends this example and that ends part 2 of the discussion. If you have any questions, you may ask your teacher. Meron pang part 3 yung discussion on the next video.